Yeah, go in.
That's it, now get close, get in.
AIC are an international steel company who've been around for quite a number of years. They're very large, particularly in the Middle East. That's where our base is. We're based out of Dubai. We have a number of centres in the Middle East in general. We have a large fabrication plant in Jeddah, another one in Ras Al Khaimah, just near Dubai. What's good about Newport is its access. It's got great access to London, for example, and the rest of the country with the M4. It's got good port access. But more importantly, I think it has the steel skills here. We've been really pleased with the sort of quality of the people we've had so far here. And effectively, AIC are known for really their technical ability. And that's one thing that we've been very keen to show the market here. So we've emphasised on our engineering ability and technical ability and the skill of our guys in the factory. Well, what AIC specialise in are particularly very engineered projects. Some of the work they've done in the Gulf, such as Jeddah Airport, use really difficult structures and highly complex engineering solutions. So we have here tried to use the fact that the engineering skills that are in the group give us an edge. One of the reasons we're involved in Bristol City is the complexity, and we have the skills here that could do that within the group, so that works very well.
The Ashton Gate project is a refurbishment project of an existing football stadium. Either stands are being completely demolished and replaced with new steel and precast concrete, or they are being modified to put into a refurbished state. AIC are responsible for the manufacture, protective treatment and installation of the structural steelwork, and also for the installation of the precast terracing units. The complexity of working in and around a live football stadium is the challenge.
To put that truss up on a particular date, there was a huge involvement from people. Before any steel can be processed, we've got a lot of engineering to do, and again we've got some really good people to do that.
My involvement in the truss build starts when detailed drawings land on my desk. From there we plan how we're going to build the job. The constraints on the truss build were due to the size of it. 7.5 metres at the base, 4.5 metres high triangular truss section is obviously a large chunk of fabrication. Starting on a flat on the floor, building the side of the truss for each side, and then going up into the triangular truss. After fabrication, the truss sections are moved into our paint shop, where we've got one of the largest manual blasters in the UK that can be used to blast up to SA3 and give us a good range of painting and blasting capabilities, and then painted to the specification. From there, once the paint is dry and checked and everything is correct, they are loaded onto a specially designed frame to enable us to transport the truss to site. Due to the size of the truss, it had to be set at an angle on the frame. We did this by doing some temporary works which attach to the frame and then placing the truss up an angle.
It's always a challenge, the logistics of getting the product life cycle from design through detailing and into manufacture is always a challenge. That's alongside then the actual logistics of travelling or transporting these parts and products to site. It's always planned up front in design and detailing so that we can make sure that the parts being delivered by road transport can physically get to the site. Travelling at about 280 millimetres off the floor at the lowest point. So.
For obvious reasons, the truss was transported in the early hours of the morning to eliminate disruption on the roads due to the size of it. So the route to site is planned to see if there are any other obstacles.
The route was checked about 5 times, and our transport and logistics guys made sure that they checked every single dimension so that we could make the fabricated elements get to site. Fabricating, welding, and then assembling and welding 8 units together over 100 metres and making it fit between 2 points is quite a challenge. Projects like this where you have a critical lift, we have a series of pre-lift meetings with risk registers and checklists, and this goes down to bolt level detail. As a team, we sat down on a number of occasions and eventually the day before to make sure that all pre-checks were done prior to lift. The issue is that it was decided that we would build the 100 metre long truss, which is approximately 75 tonnes on the ground, so that we're minimising height work. And the added challenge is that we were building it 1.5 metres from the pitch line. So the groundsmen were very sensitive about the possible damage to the pitch. So we came up with the solution where we were able to travel 2 200-ton cranes on the pitch. Surveys were done beforehand and surveys were taken after we finished the lift, and the pitch was undisturbed.
What AIC in Newport here, we've been trying to engage with the major contractors in the UK because we want to be a partner with them, and we feel we've got the solutions that we can give them, particularly on more complex jobs, but ideally of a certain size, from 200 tonnes to 2,000 tonnes. So within that sort of reach is where we feel very comfortable. Because we have, as you see in the factory, it's got quite a capacity. So we feel we've got the capability to work with the really big players in the UK. Well, what's next for AIC? We'd like to think that the Ashton Gate is an example of what we can do as a new company. We're engaging very closely with some of the major contractors in the UK, and we're talking about some really seriously interesting projects. We've been very successful, and we'd like to think that this is just the start of the success of where we're going to go.